Last week we created frequency tables. In this topic we're going to look at interpreting those tables. So this is the frequency table that we looked at before, restaurant arrivals data. And you can see the first column is the discrete number of arrivals in each time period. The second column is the frequency, and the third column is the relative frequency. So straight away we can see that the relative frequency of one arrival is 4%, and the relative frequency of four arrivals is 8%. So four arrivals is twice as likely as one arrival. The most frequent value, the mode, is 8, and the least frequent value is 10. So there's 8 arrivals, happens 21% of the time. 10 arrivals happens only 2% of the time. And we can also band our frequencies and relative frequencies into larger groups. So we might be interested in saying, what's the probability or what's the frequency of 5 to 7 arrivals? That's everything between this area and this area, and it's 3 times 10, 30%. So there's a 30% chance of 5 to 7 arrivals. Interpreting graphs. We can also interpret graphs. This is the chart for the sports data presented in the previous topic. You can see along the x-axis at the bottom the bands for sports ticket prices from the 200s in the left-hand side, $200, over to the $699, $700 on the right-hand side. This is a combination chart, a combo chart. The frequency is charted as blue columns against the left-hand y-axis. So you can frequency there on the left running from 0 to 10. And the cumulative frequency on the orange line is charted against the right-hand y-axis, going up from 0 to 100%. And that cumulative frequency chart, that line is called the ogive. So we can interpret this, gives us a very clear representation. The first thing we can see that stands out from the chart is that the 3 large bars and the next 5 lower bars indicate that ticket prices are concentrated at lower prices. So most of the tickets are sold at the under 339 at the ticket prices below 399. And the ogive then also specifically at point 3 shows that this block of 3 high columns at the left makes up 80% of tickets. So 80% of tickets are under the 350 mark. So these 2 points stand out quickly from a chart. So graphs can be used not only to represent data, but to misrepresent data if not interpreted correctly. Here we've got the average number of actual weekly hours of work in a number of EU countries. You can see in this chart that there's quite noticeable differences between each country. For example, between Germany and Sweden, there's quite a large difference in weekly hours. Ignoring the figures, you can see that the bar for Germany looks to be about a quarter bigger than the bar for Sweden. So you might think that the Germans work, the Swedes work only 3/4 of the amount of time that Germans work. But when you look at the actual numbers, you can see that Germany is 40.4 and Sweden is 38.6, which is only about a 10% difference. So let's take a look. So the reason for that difference is that the axis at the bottom, the number of hours, this is actually a y-axis, but the chart is turned on its side. It starts at 36, right? So that's the reason for the bars looking relatively spread out, because the focus has been zoomed in so much. Take a look at the same data. Here we have the same data, but in this instance, the axis for the chart, the counts, has been reset. The base for that has been reset to 0. And when you look at that, you can see there's a much less of a difference between the countries. And you can see that the difference in the column between Germany and Sweden is not as great. Now, it's important to understand that interpretation always depends on the context. So it's not correct to say that one chart is absolutely wrong and one chart is absolutely correct. The left-hand chart is useful if you simply want to see the order of things, because the differences in the column heights is more clear. So if you're just interested in the fact that Germany is higher than Sweden and Germany is the third in the ranking, then and Sweden is fourth from the bottom of the ranking, well, then that left-hand chart is valid. In that case, you're thinking of them as ordinal numbers. You're sorting things in order. But if you want the absolute amounts, if you want to say, is Germany 10 times as much than Sweden, or 10% more, or 20% more, then you're thinking in terms of real numbers. And in that case, you need to have the base 0. So it depends, interpretation of chart data and representation of chart data depends on the context. This is another example of graphical misrepresentations. Here in this chart, you can see average annual global temperatures in Fahrenheit from 1880 to 2015. You can see here the bottom of the x-axis is the time series from the years 1880 to 2015, and the y-axis is the temperature in Fahrenheit between 0 Fahrenheit and 110 degrees Fahrenheit. And you can see by looking at that chart that there's very tiny little variations over the time in the annual global temperatures. Now this chart is misleading because the y-axis is so large. The reality is that global temperatures cannot go down very, very much or go up very, very much. There's no possibility of global temperatures in a realistic environment being at 110 or down at 0. And very small changes in those temperatures can make enormous differences. So we're zoomed out far too much. The y-axis is definitely misleading and reducing our ability to interpret the data. If we correct that, here on the right hand side you can see the same chart roughly, but the y-axis is set from 55 to 60 because in an ecosystem global temperatures can only really vary by even over thousands of years by orders of individual or maybe 10 degrees Fahrenheit, not 50 or 60 Fahrenheit. Now when you look at this data, you can see a trend straight away. So looking at the chart, you can see that from 1880 up to 1970 approximately, temperatures do go up and down, but there's more or less roughly a constant global average temperature. And then from 1970 onwards, it's a steady increase. So that's achieved by looking at the appropriate scale, knowing the problem, and that's a way of properly representing data in a graph.